So to start today's lesson, I want you to take a moment to consider this problem. Pause the video, try it, see how you would think about approaching it, what skills do you think you need, and then hit play. All right, now that you've had a chance to try this problem, let's look at it. It says your local grocery store is giving a $10 gift card to every 6th customer and a t-shirt to every 8th customer. Let's make sure we understand what that means. That means if you're customer number 6 in line, you're going to get a $10 gift card. And every 6th person after that will also get a $10 gift card. So the 6th person, the 12th person, so on and so forth. So which customer will be the first to get both prizes? You're to draw a picture or chart to explain your answer. So when I look at this, I think about drawing a chart that shows who's going to get which prizes. So when I look at this, I can say, well, if every 6th person is going to get a gift card, then that means it's going to be person number 6, and it's going to be person number 12, it's going to be person number 18, it's going to be person number 24, it's going to be person number 30, and I could keep going on and on and on through however many customers there were at the store. Now, when I look at the t-shirt said every 8th customer is going to get the t-shirt. So every 8th customer means person number 8, person number 16, person number 24, so forth and so on. So the first customer to get both prizes, I can see from my work here, is person number 24. Now, when you look at this, you hopefully realize that what you're doing is you're using what are called multiples of 6 and 8, and you're looking for where they have a common multiple. So first, let's make sure we know what multiples are. A multiple is what you get when you count by a number. In other words, a number is going to always go into its multiples evenly because you're counting by that number. So if multiples of 3, for example, would be 3. We have to start with 1 times the number. 1 times 3 is 3, so 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. And we could keep going on and on and on forever. One of the differences between factors and multiples, we can tell how many factors a number has. For example, 3 has 2 factors. 1 and 3 are its only factors. But it has an infinite number of multiples because multiples keep going on and on forever, just counting up 3 every time. Now, what we were really looking at is LCM, or least common multiple. And least common multiple is the smallest multiple that 2 or more numbers have in common. So that makes sense because that's what we were really looking at here for the 6 and the 8. We were looking at counting by 6s and then counting by 8s and seeing where they had the same number. So one way we can find a least common multiple is we can use a listing method. And what that means is we list our multiples of each number and we compare our list and we see what is the first number that's going to appear on both lists. So if I'm looking at the 6 and 8 like I just was, for example, the 6th person, the 12th person, the 18th person, then the 24th person, then the 30th, and I could keep going on and on and on. But I usually say if you're going to do it this way, maybe do the first 5 multiples, see if you have, imagine if not, keep going on a little ways. For the 8th, for 8, I could do 8, 16, 24, 32, 40, so forth and so on. And as I look at that list, I can see that the first number that appears on both lists is 24. So my least common multiple, or LCM, is 24. So I can pick that out fairly easily by using that method. Now I will say myself, when I'm doing this, I usually don't necessarily write both lists out because I'm a big believer in let's work smarter, not harder. What I would maybe say is really pick your bigger number, which is the 8, and think of multiples of 8. 1 times 8 is 8. Does 6 go into that? No. 2 times 8 is 16. Does 6 go into that? No. 3 times 6 is 24. Does 6 go into that? Yes. So 24 is my least common multiple. So in that method, I'm finding the multiples of one of the numbers and using that as a checklist for the other one to see where the least common multiple is. So you don't necessarily have to write multiples of both numbers. So that's one of our methods. Our second method is going to be our tic-tac-toe, or our upside-down division. And this is a lot like, again, what we did for GCF and what we did with prime factorization. We're doing upside-down division, or tic-tac-toe ladder. That's what it's going to look like. So in this case, we're looking for the LCM of 12 and 20. So we're going to look for any common factor of 12 and 20. So a common factor of 12 and 20, one common factor would be 2. So now I'm going to divide both 12 and 20 by 2, and that's what's going to go underneath of those numbers. So 12 divided by 2 is 6. 20 divided by 2 is 10. Now I look at the 6 and the 10. And I say, well, is there any common factor of 6 and 10? Yes, there is. 2 is a common factor of 6 and 10. 6 divided by 2 is 3, and 10 divided by 2 is 5. Now look at those answers, 3 and 5. Are there any common factors of 3 and 5? Yes, but that only common factor is 1. So when you get to the point where your only common factor that you have left is 1, that's when you're done making your chart, if you remember. So then I'm going to do what I did for GCF and look at the numbers on the left, but I'm going to make the L. In other words, make it look like an L and take those numbers along the bottom as well. So my LCM is going to be 2 times 2 times 3 times 5. And if I actually multiply that out, 2 times 2 is 4, times 3 is 12, times 5 is 60. The least common multiple of 12 and 20 is 60. Now I want to point out to you what this actually is doing for you is when we look at our prime factorization of 12 and prime factorization of 20, if I were to use the prime factorizations, the prime factorization of 12 is 2 times 2 times 3. 2 times 2 times 3. The prime factorization of 20 is 2 times 2 times 5. So if I were looking for GCF, if you remember, we find our common primes, which are 2 and 2, and so our GCF would be 2 times 2. But when we do LCM, we're going to do 2 times 2, and then we use the ones that are left over, which are the 3 and the 5. So 2 times 2 times 3 times 5. Notice that that matches what we did with our ladder or our tic-tac-toe method. So you could certainly do your factor trees or your upside down division and find the prime factorization of each number and compare them that way. Or you could use the tic-tac-toe, and that's going to do the same thing. It's going to do the comparing of the prime factorizations for you without you actually having to do the prime factorizations. But either method would work. All right, let's take a look at a few examples. So the least common multiple of 6 and 16. When I look at those, I'm going to say, well, 2 goes into both 6 and 16. 2 goes into 6 3 times. 2 goes into 16 8 times. When I look at 3 and 8, they have only 1 as a common factor. So I could pick out my LCM by doing 2 times 3 times 8. 2 times 3 is 6. 6 times 8 is 48. The least common multiple of 6 and 16 is 48. Now what about 8 and 25? If I look at 8 and 25 and start thinking about common factors, well, the only common factor I can come up with is 1. So if the only common factor you have is 1, then all you need to do is multiply the two numbers. The least common multiple of 8 and 25 is going to be 200. So when you multiply two numbers, the answer you get is definitely a common multiple, but it's not always the least common multiple. The only time it's the least common multiple is if the two numbers have a greatest common factor of 1, like they do in this case. But on one like we did before this, 6 and 16 have a greatest common factor of 2. So therefore, they have a common factor other than 1. Therefore, you can't just do 6 times 16. 6 times 16 is 96, and that would be a common multiple, but there is a lower common multiple. That's the 48. All right, let's look at 10 and 12, the least common multiple of 10 and 12. If you want to, you can pause, take a moment, try it, see what you get, and then compare. All right, I look at 10 and 12, and I see that 2 goes into both of them. 2 goes into 10 5 times, 2 goes into 12 6 times. Then I look at 5 and 6. Their only common multiple is 1, so I'm done factoring. And my least common multiple is going to be 2 times 5 times 6. 2 times 5 is 10, times 6 is 60. My least common multiple will be 60. Let's look at one more example. Again, if you want to try this on your own and then hit pause while you try it, then hit play and see if you're correct, go for it. All right, so when I look at 16 and 12, I might again start with 2. 2 goes into 16 8 times, 2 goes into 12 6 times. 8 and 6 have a common factor of 2, so I need to divide them both by 2. 2 goes into 8 4 times, 2 goes into 6 3 times. 4 and 3 have no common factor other than 1. So now I'm ready to find my LCM. Now notice I could find my GCF. My GCF, my greatest common factor, will be 2 times 2, which is 4. But my LCM, I got to come around the corner and make the L. So my LCM would be 2 times 2 times 4 times 3. 2 times 2 is 4, times 4 is 16, times 3 is 48. So my least common multiple of 16 and 12 is 48. Now, if you're really up for a challenge, give this a shot. See if you can find two numbers that have the given least common multiple. Pause it while you're trying and then hit play and check and see if you're correct. So here's the answers that I got while working this out. It's perhaps possible to get other answers, but these are certainly right answers. One thing I want you to notice is that if you look at that first example for a least common multiple of 8, notice that one of your numbers can be the least common multiple. If one number is a factor of the other one, for example, like 4 is a factor of 8, then that means that the bigger number will be your least common multiple. So it's okay for one of the numbers to be your least common multiple. Hopefully this has given you a good overview of least common multiple, and the more you practice your multiplication tables, the easier this is going to be for you.